Hi, George Diamond here again. We're continuing our video series on calculus topics. Now today we'll be looking at section, in our textbook, what is section 2.5, implicit differentiation. Now this is our second video. Now my students will recognize that I'm carrying a can of black paint with me today, and I also have a blue pencil behind my ear. So black paint and a blue pencil. Let me set these down. And we're going to get started with our video now. So we're looking at, in this second video, we're mainly just doing some examples. In the first video, we talked about implicit differentiation. We looked at the difference between implicit and explicit form of functions. So here we're just looking at some examples. How to take the derivative of a function implicitly without solving the function for y. Because remember, some functions, some equations, are very difficult to solve for y, but we can take the derivative very quickly without rearranging them or doing anything to them, so we can take the derivative the way they sit. Now we're going to start off here with x squared plus y squared equals 4. Now I've got my smart board up. I got the lights turned down, so I'll kind of be a little bit dark maybe, but hopefully you'll be able to see the problems and things and the examples as we work each one of these out. Now it says we're going to find the derivative of each one of these using implicit differentiation. So let's start off with the first one. X squared plus y squared equals 4. Now x squared plus y squared equals 4 is an equation of a circle with a radius of 2. So let's take a look at our derivative. Now if you remember from our first video, I said we'll start off by taking the derivative of the x squared term. Now we all know how to do that. Derivative of x squared is 2x. Okay, plus. Now let's take the derivative of y squared. Now if you remember from the first video, we said you take the derivative of y, of a y factor, just like you do the x factor. But you must leave dy over dx as a factor in the derivative. So the derivative of x squared is 2x. Well, the derivative of y squared is 2y times dy over dx equals. So that's the derivative of y squared. You have to leave dy dx as a factor. And remember, this is because of the chain rule. And then last, we got to remember to take the derivative of the constant here. If there's a number on the other side, the derivative of 4 is 0. One of the biggest mistakes that my students have always made in the years past, using implicit differentiation, they'll take the derivative of x squared and y squared and forget about the 4. They just tend to want to bring the 4 down. But remember now, if you take the derivative of one term, you got to take the derivative of every term in your equation, including the 4. And the derivative of a constant is 0. So, now remember our different steps. You take the derivative of your expression with respect to x, or your equation with respect to x. So each term. Okay, we've done that. Now you want to get all terms that have dy dx on the left, all the other terms on the right. So we're going to move this 2x to the other side. Positive on this side, it's going to be negative on that side, so we end up here with 2y times dy over dx is equal to negative 2x. Bring it on down a little bit. Now we only have the dy dx term, so there's no factoring involved here. But we do have to solve for dy over dx. Now to solve for dy over dx, you have to get rid of the 2y that's being multiplied to it. So we divide this side by 2y. Right, to get rid of that multiplication, and we're going to divide this side over here by 2y also. Now so dy over dx. Right, this is our last step, is to solve for dy over dx. Once you get dy over dx by itself, you have the derivative now. Now on the right-hand side, what happens is you have negative 2x over 2y. The 2's will cancel. This will give us negative x over y. This is our derivative now. So negative x over y. Okay, let's try another example. So come on over. Okay, let's try a little bit longer example this time. Let's try this right here. So once again, we'll see if we can find the derivative using implicit differentiation. Now notice we've got 1, 2, 3 y terms that have y in them. We got one x term and a constant term. Now we got to take the derivative of each term the way it sits. Now remember now, every time you take the derivative of a y term, you do it just like you would if it were an x term, but you got to leave dy over dx as a factor. So let's do the y cubed first. The derivative of y cubed would be 3y times dy over dx plus. So that'll be the derivative of the y cubed term. Just you got to leave the dy dx as a factor. Now the derivative of y squared would be 2y times dy over dx minus. Now the derivative of negative 5y. Remember that the derivative of negative 5x would be negative 5. So the derivative of negative 5y would be minus 5 dy over dx. Now the derivative of negative x squared would be negative 2x. And the derivative of negative 4 is 0. So this is the derivative of each term the way it sits. Now notice, we got 3 dy dx terms when we take the derivative the first time here. So we got 3 of them. They're all on the left-hand side of our equal sign. So remember the second step after you take the derivative, you want to get dy dx is on one side, everything else on the other side. So this negative 2x here, that has to go to the other side of our equal sign. Now these 3 here we're going to bring down. This is 3, this will be 3y times dy over dx, okay, plus 2y dy over dx minus 5 dy over dx is equal to positive 2x. So bring this on down a little bit. Right. Now, notice now we've got we got 3 factors that have 3 terms that have dy dx as a factor. Those are all on the left-hand side. We move the minus 2x to the right side. It becomes a plus 2x. Now, the last step, we have to factor dy. If you have multiple or more than one dy dx terms that have dy dx in them, you've got to factor dy dx off. So let's do that. So factor dy over dx. That'll be equal to 2x. So we've got to factor dy dx off each of those terms. So the dy dx goes on the outside of your parentheses, which is basically just factoring off a greatest common factor or a common factor here. Now we're bringing the 3y down, okay, plus 2y minus 5 inside our parentheses. So we've got the dy dx factored off. And inside the parentheses is 3y plus 2y. That'll be 3y. This is 3y squared, I believe. So let me get that squared on there. So it'll be 3y squared. Plus 2y minus 5. There we go. We extend our page a little bit. Now, to finish solving this for dy dx, this is dy dx times this expression here. So we're going to divide the left-hand side by 3y squared plus 2y minus 5, and then you got to divide the other side by the same thing. So 3y squared plus 2y minus 5. So we got to divide both sides of our equal sign by the same thing. So these two are going to cancel out. And we end up with our derivative now is dy over dx is equal to 2x divided by 3y squared plus 2y minus 5. Now, that's our derivative. Now, notice now the derivative is described in terms of x and y. So most of the times, or a lot of times, you may have 2 different variables there in your derivative, which is okay. Now, so dy over dx, that is your derivative, is equal to 2x divided by 3y squared plus 2y minus 5. Now, if we're going to find this, if we need to define the slope at a particular point, okay, you use your derivative and you got to substitute in for x or y, or x and y. So you got to substitute them both in. Okay, let's try another example. Example number 3. Let's try this one here. Now, first thing you want to recognize here, we got x squared times y plus y squared times x equals negative 2. Now, to take the derivative of this particular equation, okay, taking the derivative of x squared y, you got to recognize we have not one, but 2 products. So you got x squared times y. Now, this is a product. Now, that means using the product rule. Okay, also, we got another product here. So we got 2 products in the same equation. So we're going to use the product rule 2 times. So not just once, but twice. So let's take the derivative of x squared times y. Right, so here we go. Now, remember the product rule now. So first times the second plus the second times the derivative first. So we'll bring the x squared down times the derivative of y. Now the derivative of y is 1 times dy over dx, or just dy over dx. Okay, plus, that's the first times the second, plus the second, which is y, times the derivative of the first, which is 2x. Okay, plus. Now, that's the derivative of x squared y. So x squared times dy over dx plus y times 2x. Now, let's take the derivative of x squared, or y squared times x. Now, this is another product. So once again, we got to use the product rule again. So bring the first term down, so y squared times the derivative of x, which is 1, plus, so the first times the derivative of the second, plus the second times the derivative of the first. So, so you got x times the derivative of y squared, which would be 2y, times dy over dx. Now the derivative of negative 2 is 0. So once again, we have 0 on the other side of our equal sign. Now, let's see if we can simplify this a little bit, kind of clean it up. We have x squared times dy over dx. Y times 2x will be plus 2xy. Plus y squared times 1 would just be y squared. Okay, plus x times 2y would be 2xy. Dy over dx is equal to 0. So let's bring this down some. All right, so far now, you notice now as you get our derivative, we simplified it a little bit. Remember now, that's our first step. Take the derivative of the equation the way it sits, all right, with respect to x. And we've done that. Next, you want to get all terms that have dy dx on one side of your equal sign, everything else on the other side. So the 2xy and the y squared have to go to the right-hand side, and we're going to leave the dy dx factors on the left. So let's see, as we bring this down, this would be x squared times dy over dx plus 2xy times dy over dx. Now this will be equal to, now moving the 2xy to the right-hand side, we'll make that a minus 2xy. So remember to change the signs on it when you take it across your equal sign. Let's move the y squared over, it becomes a minus y squared on the right-hand side of your equal sign. So we got step 3 done. All right, so we've got, actually step 2, I guess. We got dy dx on one side, all those factors. So all the terms that have dy dx as a factor, everything else on the other side of our equal sign. Right, now, the third step, we've got to factor dy dx off. So this will be dy over dx times x squared plus 2xy is equal to negative 2xy minus y squared. All right, so factor dy dx off both of those terms. Right? And to finish this up, we want to divide both sides by x squared plus 2xy. Remember, the last step is to solve for dy over dx. Now these two are going to cancel out. Let's divide this side over here by x squared plus 2xy. So our derivative should be dy over dx is equal to negative 2xy minus y squared, okay, divided by x squared plus 2xy. Right, so let me double check my notes here to make sure we don't have any mistakes. Okay, this is it. All right. So this is it. So once again, you just have to be very careful. We're going to take the derivative. The first thing, take the derivative the way it sits. Right? After that, you're going to get dy dx is on one side, everything else on the other side of your equal sign. In the third step, you factor dy dx off. If you have more than one factor of dy dx, you factor the dy dx off and then solve for dy over dx. So this is our derivative here, negative 2xy minus y squared divided by x squared plus 2xy. So let's try this. Another example, example number 4. All right, so let's take this a step further. So we're not just going to find the derivative, we're going to find the slope at the point 1, 1. So remember now, the derivative gives us a slope. It's an expression for our slope. All we got to do is substitute in and that'll give us our derivative. Now, to take the derivative, to start off, let's get the derivative the way it sits. Right, so we're not going to try to rearrange it or anything. The derivative of x cubed is 3x squared, okay, plus. And you take the derivative of y cubed the same way, but remember now, you got to leave dy dx as a factor. So this will be 3y times dy over dx, and that will be equal to. Now on the right-hand side, you have 2x times y. Right, now, if you look at this here, this is a product. So 2x times y is a product. So what I'm going to do is I'm going to group the 2x and then times the times y. So 2x will be the first, y is going to be the second. So as we describe the derivative of the right-hand side of our equal sign now, using our product rule, we have 2x times the derivative of y, which is dy over dx. Okay, plus, so the first times the derivative of the second, plus the second times the derivative of the first. Now the derivative of 2x is 2. All right, now we've taken the derivative the way it sits. That's the first step. The second step, we're going to have to get all terms that have dy dx in them, we need to get them on the left-hand side of our equal sign, everything else on the right-hand side. Now that means I need to move the 2x dy dx on this side, change the signs. The 3x squared has to go to the right-hand side. So we'll bring the 3y dy over dx down, minus 2x times dy over dx. And this will be equal to 2y minus. The 3x squared is positive on this side. When you take it to the other side, it becomes a minus 3x squared. Okay. Now we got the dy dx's on one side, everything else on the right hand side of our equal sign. Now let's factor dy dx off. So this will give us dy over dx times. Now that factor off the first term will give us 3y minus 2x equals. Now on the right hand side we'll just bring this down. So this will be 2y minus 3x squared. So we're going to take our derivative. Okay, and let's see, one more thing, right here should be 3y squared. I just noticed that should be 3y squared. And as we bring this down, this will be y squared here. And this will be 3y squared minus 2x. Gotta make sure you remember the exponent, I just noticed that. So if you take the derivative of y cubed, it will be 3y to the second power. So this will give us 3y squared inside our parentheses here. And we're just about finished. We just have to finish solving for dy over dx. And then we're trying to get our slope at the point 1, 1. Let's divide this side over here by 3y squared minus 2x. Let's divide the right hand side by 3y squared minus 2x. Right, and that should give us our derivative. So these two are going to cancel out. So we extend our page here. So we have now dy over dx is equal to 2y minus 3x squared divided by 3y squared minus 2x. This is our derivative now. Remember, now we're trying to get our slope. So this will be we need to get our slope at the point 1, 1. That's at the point 1, 1. So that means substituting 1 in for x, 1 in for y. Let's see what we get for our slope now. So dy over dx is going to be equal to, so to get our slope. And so our slope should be, let's see, 2 times 1 minus 3 times 1 squared divided by, let's extend our page here, so divided by 3 times 1 squared minus 2 times 1. So this expression right here should give us our slope now. So as we simplify here, this will be what, 2 minus 3 over 3 minus 2, which would be negative 1 divided by 1, which is negative 1. So this is our slope. So the slope at the point 1, 1, that would be the slope of our tangent line, is negative 1. So just like always, find your derivative, plug in for x and y, because you're going to have you have x and y with most derivative whenever you use implicit differentiation. All right, let's try example number 5. Let's try a trig function. Right, so my students kind of have more trouble with some of the trig problems than they do some of the other types of problems. So let's try this problem here. Now, once again, as we take our derivative, now, first thing you notice now, you got x times cosine y equals 1. And we're going to find the slope at the point 2 pi over 3. Now, once again, x times cosine y. And as you notice your equation here, x cosine y, this is a product. So to take the derivative of x cosine y, you have to use the product rule. So let's get started. So this will be the first term. Now the derivative of cosine, remember, the derivative of cosine x is negative sine x. So the derivative of cosine y would be negative sine y times dy over dx. So times dy over dx. So that's the first times the derivative of the second plus the second. So the first times the second plus the second, which is cosine y, times the derivative of the first, which is 1. That'll be equal to the derivative of 1 is 0. So don't forget the right-hand side of your equal sign. Make sure you take the derivative of the constant also. So the derivative of 1 is 0. So it's x times negative sine x dy dx plus cosine y times 1 equals 0. Now I notice immediately, we only have the 1 dy dx factor. So let's move this cosine y to the right-hand side of our equal sign. Change the sign. So we end up here with negative x sine y dy over dx equals negative cosine y. Right, so move that cosine y to the right-hand side of our equal sign. And as we finish this up, now we've got we've got to solve for dy over dx. So let's divide this side by negative x sine y. You can divide this side up here by negative x sine y. Okay, now we're almost done. Now, first of all, the two negatives here cancel out. So make that, we end up with positive cosine y over x times sine y. Now let's see, we got to get our slope now at the point 2 pi over 3. So to get our slope, now we'll have extend our page here a little bit. There we go. Now we got to substitute. See, this is at 2 pi over 3. So at 2 pi over 3. Now we got to substitute 2 in for x, pi over 3 in for y now. All right, so let's see what we get for our slope. And let's see, this is cosine y, so this will be cosine pi over 3 divided by x, which would be 2 times sine y, which would be sine pi over 3. Okay, now let's see if we can simplify this. Now remember cosine pi over 3 and sine pi over 3. Remember the unit circle? So remember your unit circle, pi over 3 would be about right here. And the coordinate for pi over 3 would be 1/2 square root of 3 over 2. And so remember now, cosine is the x value and sine is your y value. All right, so as we evaluate this, cosine pi over 3 then would be 1/2 divided by 2 times sine pi over 3. Now sine pi over 3 would be the square root of 3 over 2. Okay. Now, to get our slope, we just have to simplify this expression a little bit. Now, we kind of extend our page here some. Now, first of all, the 2 times pi over 3, the 2's will cancel out. And we end up with 1/2 divided by the square root of 3 over 1, right? And then simplifying this will be 1/2 times 1 over the square root of 3. So our slope then becomes 1 over 2 times the square root of 3. So this is our slope at 2 pi over 3. So this is it. So that'll be our slope. So 1 over 2 times the square root of 3. Now you could rationalize it. You could get the radical off the square root of 3, but I think this will be good for our slope. Okay, let's try another example. Let's try just a plain derivative this time. So we're looking for the derivative of cotangent y equals x minus y. So let's try a little derivative here. So to start off, now I don't see any products here, just cotangent y equals x minus y. So you don't have to use the product rule again or anything. So as you take the derivative, now the derivative cotangent, this is one of those trig functions you have to have memorized. So when you see cotangent, right away you need to think of the derivative. So the derivative is negative cosecant y. Now this is in terms of y, so it'll be negative, so cosecant y times dy over dx. Now that'll be equal to, so the left-hand side, this is our derivative. So negative cosecant squared y. So negative cosecant squared y times dy over dx. Now that'll be equal to, now the derivative of x is 1 minus, and the derivative of y is dy over dx. So you're taking the derivative of y with respect to x, which is 1, or just dy over dx. Now you'll notice here we've got 2 terms that have dy over dx in them. So we need to move this dy dx term to the left-hand side, and that'll give us dy over dx minus, so cosecant squared x, SC, squared y rather, so negative cosecant squared y times dy over dx equals 1. Okay, so let me bring this on down. Now you got your dy dx is on one side, now we got to factor dy dx off. So let's put the dy dx down here. And let's see what we have left inside our parentheses. Now you take the dy dx off, dy dx leaves you 1 minus, and this will leave us with cosine, cosecant squared y, all right? So cosecant squared y, that'll be equal to 1. And to get our final derivative, you got to divide this side by 1 minus cosecant squared y, so these will cancel. You divide this side over here by 1 minus cosecant squared y. And this is our derivative then. So dy over dx is equal to, this would be 1 over 1 minus, so cosecant squared y. So this should be our derivative then. Right, basically in terms of y, so there's no x's left here, so just in terms of y. So this is our derivative. Okay, let's try problem number 7. So number 7. Now once again, we're just finding the derivative, right? Not the slope or anything, so just the derivative. Now immediately, this is another trig problem, so right away you got to recognize, now 2 sine x, cosine y, that's a product again. So we're going to have to use our product rule to find the derivative. So let's start off. Now 2 sine x will be the first function, cosine y will be the second function. So start off, let's get our derivative now. So bring the 2 sine x down. So the first times the derivative of the second. Now the derivative of cosine x is negative sine x. So the derivative of cosine y would be negative cosine y times dy over dx. So the first times the derivative of the second plus the second, which is cosine y, times the derivative of the first. Now the derivative of sine x is cosine x, so the derivative of 2 sine x would be 2 cosine x. And that'll be equal to, the derivative of 1 is 0. Right? So go ahead and take the derivative of the left-hand side. And the left-hand side, remember this is a product, so you have to use the product rule. So the first times the derivative of the second, so 2 sine x times the derivative of cosine y, so the first derivative of cosine, so the first times the derivative of cosine, now let's see, the derivative of cosine y is negative sine y. Let me get that right. So negative sine y times dy over dx. The derivative of cosine is negative sine. Okay, plus cosine times the derivative of sine, which would be 2 cosine x. So this should be our derivative here. And let's see, looks like we only have the one dy dx term. So let's see, we only have the one dy dx term, so this should be pretty easy to solve for dy over dx. So let me see if I can rewrite this a little bit. We'll pull the negative out front. This will be negative 2. So negative 2 sine x. So negative 2 sine x times sine y. Okay, dy over dx. Now let's move this term to the right-hand side. Now this is going to equal negative 2 cosine x sine y. Cosine y. All right, so we'll move this term, this product to the right-hand side of our equal sign. That way we have the dy dx term on the left-hand side. Now we only have the one dy dx term, so all we have to do now is solve for dy dx. That means getting rid of the negative 2 sine x sine y being multiplied to it. So we got to divide this side by negative 2 sine x sine y. These two cancel out. And we're going to divide the right-hand side by negative 2 sine x sine y. So negative 2 sine x sine y. All right. Now we're almost done. Dy over dx should be equal to. Now let's see if we can simplify this. Now the negative 2's cancel out immediately. Now also I notice now as I look at my answer here, we have cosine x cosine y divided by sine x sine y. Now I know that, doesn't cosine over sine equal cotangent, right? So we got some cosine x over sine x times cosine y over sine y. So we should be able to write our derivative as cotangent x times cotangent y. So the final version of our derivative should be this right here. So cotangent x times cotangent y. Okay, let's try another one. So this is a little trig derivative. Okay, let's try the second derivative. Right? So we've done several examples so far. Let's try a second derivative problem. So finding the second derivative. All right, now we know how to find the first derivative. Here we have y squared equals 4x. So let's take the derivative the way it sits. All right, so let's find the first derivative first. Or to begin. Now, taking the derivative of y squared, once again, 2y times dy over dx. Now, so that'll take the derivative of the left-hand side. So remember, the derivative of x squared is 2x. So the derivative of y squared is 2y. And then you've got to leave dy dx as a factor. Now, on the right-hand side, the derivative of 4x is 4. Okay, now all we got to do, we only have the one dy dx term. So let's solve for dy dx. So let's divide the left-hand side by 2y, divide the right-hand side by 2y. These are going to cancel. We end up with dy over dx is equal to 4 over 2y, and this will simplify to 2 over y. Okay. Now, we got the first derivative. So the first derivative is 2 over y. All right, so we got the first derivative. Now, to get the second derivative, we're going to take the derivative of 2 over y. Now, you could use the quotient rule, but for a little fraction like this, we don't need to. Let's write 2 over y is 2y to the negative 1 power. So remember, this is 2 over y is the first. All right, so we're going to rewrite that as 2y to the negative 1 power. Okay, now, so our first derivative is 2y dy over dx equals negative 2y to the negative 1 power. This will be a little bit easier for us to take the derivative now. So as we take the second derivative, now we're going to indicate the second derivative like so. So d squared y over dx squared. So the second derivative we're going to indicate like this. So as you take the derivative now, you're taking the derivative of negative 2y to the negative 1. So remember now, you got to take the, you have to leave dy dx as a factor on the right-hand side of your equal sign as you take this derivative. So we do negative 2 times negative 1 times negative 2 gives us positive 2y. Now remember, you got to subtract 1 from your exponent, which gives us the negative 2 power. And let's see, actually, this should be a positive 2, I believe, isn't it? So it should be 2y to the negative 1 power. So if you bring it down, then this will be a negative 2y to the negative 2. All right, so and then you have to leave dy over dx as a factor. So dy over dx, and this should be our second derivative. So once again, rewriting the derivative is just 2y to the negative 1. It should be a positive 2y to the negative 1. So negative 2 times negative 1 times 2 gives us negative 2. Subtract 1 from your exponent gives us y to the negative 2 power. So this is our second derivative. Now one thing I want you to notice about the second derivative, and in most cases this is going to be true. The second derivative is going to have the first derivative in it. So notice now, the second derivative equals negative 2y to the negative 2 power times dy over dx. Extend our page here a little bit, which is equivalent to the negative 2 will go on top of our fraction y to the second power times dy over dx. Now, so typically when you get the second derivative, a lot of times the second derivative will contain the first derivative. Now, if you remember the first derivative was y over 2. So we don't want to leave the second derivative with dy over dx in it. So we have to make a little substitution. Let's take the 2 over y, and let's substitute it in for dy over dx. That's the first derivative, so we're going to get rid of the dy dx by substituting here. So let's substitute this in, and we end up here with negative 2 over y squared times, now we said this is 2 over y, so times 2 over y. So instead of dy over dx, we're going to replace it with 2 over y. And now we just multiply. So the second derivative should be negative 4. Y squared times y gives you y to the third power. So this is the final version of our derivative, of the second derivative. So you don't want to, if you can, you don't want to leave the second derivative with dy dx in it. So dy dx is simply the first derivative, so you need to make a little substitution to get rid of the dy dx. So a little something to remember now, anytime you're going to take the second derivative using implicit differentiation, many times, I would say most times, it's going to have dy dx in it, but you can remove it by simple substitution, right? Because you already have the first derivative, you just have to plug it in, right? Now let's try another example using implicit differentiation. Let's try a little circle. So x squared plus y squared equals 25. Again, let's see what the second derivative here would be. Now let's take the derivative of each term. The derivative of 2x is of x squared is 2x plus. Now the derivative of y squared would be 2y times dy over dx. And the derivative of 25 is 0. Once again, remember, you got to take the derivative of the constant. If there's a constant, you got to take the derivative of that also, which is just 0. Now, we only have the only one dy dx term, so we're going to move the 2x to the right-hand side over here, and we'll bring the 2y down, so times dy over dx, that's going to equal negative 2x. So move that 2x over. So just remember, change the sign on it when you take it to the other side of your equal sign. Now, to finish solving for dy over dx, we're going to divide this side by 2y. 2y's cancel. Let's divide this side over here by 2y also. And our derivative is, so dy over dx equals, now here the 2's will cancel, gives us negative x over y. Okay, now that's our first derivative. Okay, now we got to take the second derivative. Now, you notice immediately dy over dx is equal to, negative x over y, that's a quotient. So to take the derivative, to get the second derivative here, we have to use the quotient rule. So you get negative x over y, that's the quotient rule. So let's see how we set this up now to find the second derivative. So let me bring this down here. So to get the second derivative, this is the first derivative. Now remember what I said. I said most times when you take the second derivative using implicit differentiation, the second derivative will contain the first derivative. So the second derivative should have, and probably will have, dy over dx in it. And we're going to have to replace it with a negative x over y. So a lot of times, or many times, most times, the second derivative using implicit differentiation will have the first derivative in it. So let's see what we get when we take the second derivative. So this will be d squared y over dx squared equals. Now, you remember the quotient rule. We start off with the bottom squared, so y squared. Now, across the numerator, you take the bottom, right, so y times, so the bottom times the derivative of the top. So the derivative of negative x is negative 1 minus. So the bottom times the derivative of the top minus the top, which is negative x, times the derivative of the bottom. Now, the derivative of y, with respect to x, remember, is dy over dx. Now, this describes our second derivative. Now, let's see if we can simplify it a little bit here. You got y times negative 1 will be negative y. It'll be minus a negative, we'll change that to plus a positive, so it'll be plus a positive. X times dy over dx, all this divided by y squared. Okay. Now, right away you notice, now like I said, when you take the second derivative, it's going to contain the first derivative. It's going to contain dy dx in it. So we got to do a little substitution here. We got to take this, substitute it into the second derivative, because you don't want to leave it. You don't want to leave the dy dx expression in the second derivative here. Now, so we got to do little substitutions. We're going to substitute negative x over y in for dy over dx, and see what we get. So our substitution, this becomes, let's see, negative y plus x times, and this will be negative x over y divided by y squared now. Let's extend our page a little bit. Now, to simplify this a little bit, let's multiply x to the first derivative. So we end up here, we'll end up with negative y plus, well actually this is, we're multiplying a positive times a negative, that'll become minus. X times x squared will give us x squared over y. So remember, when you multiply x to this fraction, you're going to multiply it to the numerator of the fraction. All right, so you end up with x squared over y, all that divided by y squared. Okay. Now we need to simplify this a little bit. And we got the second derivative, but this is now a complex fraction. You got a fraction within a fraction. We don't want to leave it like that. So we need to get rid of this little fraction in the numerator. Now to get rid of it, we're going to multiply it by its denominator. So we're going to multiply the top by y. Then you got to multiply the denominator by y also. And remember, this is going to, as you multiply y times negative y, will give us negative y squared minus. And when you multiply to your fraction, the y's cancel out, and it'll give us just x squared. So minus x squared divided by. Now in the denominator, y squared times y is y to the third power. So this will be y cubed on the bottom of our fraction. Now that's the second derivative. So that's the second derivative in terms of y and x. But we're not finished yet. Now this can be simplified further. Now what I'm going to do is I'm going to factor a negative 1 off the numerator. It'll be x squared plus y squared inside our parentheses divided by y to the third power. Now if you remember from the beginning of the problem, we said that x squared plus y squared equals 25, right? So x squared plus y squared equals 25. So let's take 25, and we're going to substitute that in for x squared plus y squared now. So our final answer becomes, for our second derivative, if you substitute this in, this will be negative 25 over y cubed. So this should be the final version of our derivative. Let me just double check my notes, make sure we're on, and that is it. So bang, we've done, I think, 9 examples. Hopefully after 9 examples, we'll be capable of using implicit differentiation to take the derivative of any function. Now, hopefully my students, they'll be prepared to use implicit differentiation here to take the derivative of any function. So using the product rule, quotient rule, etc.